Now, let's say the given angle is in radians. Let's simplify this angle as 10 pi over 3. Now, think in terms of the angle now being between 0 pi and 2 pi. But because the angle is divided by 3, we might as well write it as 0 pi over 3 and 6 pi over 3. Now, just like pi can be written as 3 pi over 3, or for that matter, any combination that allows you to reduce to simply pi. When you're talking about 2 pi, you need to go for a combination of values that will reduce to 2. So if you have a denominator, just duplicate that denominator and you'll get the value that you need on top. So 10 pi over 5, or even 8 pi over 4. So now write down the value that you're given. I have a value of 10 pi over 3. Is that value between 0 and 6? That's not the case here. So we're going to have to find a coterminal angle. So we're going to subtract 2 pi, or 6 pi over 3. We're going to get 4 pi over 3. Now, is that angle between 0 and 6? It is. So the meaning of that is that we have pi over 3, 2 pi over 3, 3 pi over 3, and 4 pi over 3. So this is 4 pi over 3. If we keep counting, this is 5 pi over 3, 6 pi over 3, 7 pi over 3, 8, 9, and we reach 10 pi over 3. So in that case, we'll know that both angles have the same initial side and terminal side. Now, about the bases, we need to think of the first being at 0 pi over 3. I'm using thirds because the angles are in terms of 3. So this would be 3 pi over 3 and 6 pi over 3. If you were working with an angle of, let's say, 4 pi over 5, you would write the bases in terms of 0 pi over 5. The next base would be 5 pi over 5, and the final base 10 pi over 5. The bases will always need to end up as 0 pi, pi, and 2 pi. And that's the case here. We have to compare the first base, 0 pi over 3. Then you have 3 pi over 3. And the final base is 6 pi over 3. So now, which one is closer to the given angle? That's 3 pi over 3. And how far are we from that base? We're simply pi over 3 away from it. So our reference angle would be pi over 3.